Hi, everyone, and welcome to the MLOps podcast. I am Dean, your host, and today I have with me Logan Kilpatrick. Logan is a graduate of computer science, law, and digital media design. He interned as a software engineer at NASA, taking part in decision support systems for planetary exploration missions. He then worked as an applied ML engineer at Apple, working on computer vision on edge device. He is currently working as a senior technology advocate at Path AI, where he leads their advocacy efforts in machine learning, engineering, and open source. And he is probably most well known for his role as the developer community advocate for the Julia language. So, welcome, Logan. It's great to have you here.
Thank you, Dean, for the introduction. I'm super excited about this conversation, and yeah, thanks again for having me.
Awesome. So let's dive into it. The question, just in case someone hasn't heard of it, that is maybe on the top of everyone's mind, is what is Julia? So can you give us sort of an overview of that?
Yeah, sure. So for folks who aren't familiar with what Julia is, it's a high-level dynamic programming language with syntax that's very similar to a language like Python, but with speed characteristics that are very similar to a language like C or C++. So you can really sort of get the best of both worlds, and that's sort of been the pitch for the last, 4 or 5 years as far as why people might use Julia. And a lot of the folks who are sort of making the transition from Python or Matlab, one of those languages, are usually coming from scientific domains. And we can talk more about some of those use cases later on, but that just tends to be the sweet spot of folks who are looking for high level syntax, but also really, really care about performance characteristics.
Awesome. Yeah, the way you describe it, it sounds to me like it matches sort of the pattern I have in my head for Go, but for scientific programmers. Like Go with Google, they tried to get the best of both worlds, like doing something that it has a similar syntax to Python, efficiency of C, but it's mainly for like back end engineering. So Julia is like for this the scientific and programming version of Go. Would that be a good way to characterize it?
Yeah, that's a generous that's a generous way of putting it. I think obviously Google has been really successful with what they've done with Go. It's widely used and it's sort of become a standard for a lot of the back end system stuff. I've never used it before, but I definitely agree that there's a lot of similarities in sort of the approach to solving sort of again like a very domain specific problem, almost like a they were trying to solve the back end problem in the context of Julia, or trying to solve the scientific computing problem. And maybe we branch out into other fields as well, but I think that's probably where a lot of the focus will be for these new programming languages that are coming up out of the woodworks these days.
That makes total sense to me. Maybe a little known fact, but the back end of DagZub is written in Go, so I have a soft spot in my heart for Go, and I think that Julia is maybe awesome in a similar way. I think that that's a very cool and necessary notion, like balancing ease of use and power, if you will, is a challenge in general. And I think when we're building tools for technical people, whether it's developers or data scientists, finding a good place in the middle is hard. Like you usually feel like you're missing out on some of the advantages at one end of the spectrum. And so I think like with Go, it's not perfect. No language is probably perfect, but I think that sort of balance of trying to take the best of each world and putting it under one roof makes total sense. But I guess we'll be talking a lot about Julia throughout this episode. I have one semi-related question, which is I am a huge astrophysics nerd. I studied physics in university as well. And I was sort of torn when I had to choose what to do research on between quantum optics and sort of astrophysics. It was, I guess, more high energy astrophysics compared to actually working on the engineering at NASA, which you did. But I'm curious, like, what did you do at NASA? How did you get there? And yeah, what technologies does NASA use?
This is a great question and a story that I've told before. So if someone is is hearing this story for the second time, I apologize, but hopefully not. I was extremely lucky to have gotten a chance to intern at NASA at the like early on in undergrad, and it literally just came about because I had applied a bunch of times on NASA's website. Nothing had really panned out through that, and I had started just messaging people in the early days of LinkedIn who were research scientists at NASA, and I was like, "Hey, really, really interested in your research. Would love to connect." Obviously, didn't really know much about their research at the time, and that ended up transpiring into somebody who I had messaged 3 months ago ended up messaging me back one day and was like, "Hey, would love to have you come in and we can chat." Went in for an interview like that next week, and they were like, "Yeah, we'd love to get you on the team." And at the time, I had joined that team that I was joining. They were using Python to do data analysis on like some of the new data that was just becoming available with a new NASA satellite that was coming online. So there was all of this new data. They were trying to sort of get as much out of it as possible. So I ended up doing that for just a few months, and ultimately transitioned to a different team at NASA. And that new team that I transitioned into happened to be using a little programming language called Julia, which ultimately led to all the other stuff that I've been involved with. So I'm very grateful that the journey ended up the way that it did. But so the second team that I was on was where I spent the bulk of my time. I was there for 2.5+ years. And really the sort of goal for that project was trying to sort of reimagine the way that NASA plans lunar traverse missions. And actually more broadly for all planetary exploration craft. So anytime we're sending a rover or some sort of craft to another planet, you don't really think about this, and I really never thought about this until I was on the team, but they don't just send the rover and then just start driving around and like trying to make scientific discoveries. There's actually all this planning that happens beforehand in order to decide like what's the optimal traverse so that we can minimize the risk for the rover, but also maximize the scientific discovery. So usually what happens is you get a bunch of experts in a room, they have a bunch of big maps, they look at the wall, they put them up on the walls, they draw traverses, they say, I've worked in NASA for 30 years, this sounds like a good idea. All that sort of domain expertise that's locked in people's heads. That was the approach, and that is an approach that they probably still use today. But what my mentor and boss at NASA, Edward Balaban, and some other folks had the idea of is, well, why can't we use mathematics and decision making to come up with an optimal mathematical answer to this problem? So they used POMDPs and MDPs, partially observable Markov decision processes, which just allow us to represent the real world environment and sort of with code to actually solve this problem. So now for the upcoming NASA Lunar Viper mission in 2024, that traverse that the rover will take is actually using the plotting and simulation tools that we built using Julia, which is super exciting.
That is a great story. So first, I guess the first takeaway from this is the first time you sort of used Julia was as part of this internship. Is that correct?
Yeah, exactly. So I had never heard of the language before, and when I joined the team, it was actually Julia hadn't even hit its 1.0 release yet. So the initial code base that I joined was in Julia 0.5 or 0.6, and my sort of first task was helping transition the project from 0.6 to 1.0 and had to go through all those breaking changes. And that was really the forcing mechanism for me getting involved in the community, just because I was like, hey, I need to get help on making this stuff work. And I've never programmed in Julia before. And, there wasn't great documentation for how to make that transition. So I was just asking a ton of questions and meeting a bunch of people, which was awesome.
That is a great story. I think sort of that serendipitous discovery and also the type of task that you're describing is really one of the best ways to discover a new technology, right? Because you are sort of constraining the discovery process to, we have this code base, we want to upgrade it. There are a lot of challenges, but those challenges require you to sort of dive really deep into the language and understand how it changes over time. So, I mean, maybe not everyone listening wants to be super expert like you are in Julia, but if you are, and I think you can very easily extend this to any language, I think that's a great way to define a task that will help you learn these things. So, I think machine learning equivalent of this is many times you take a model that was implemented in TensorFlow and now you have to re-implement it in PyTorch or vice versa. So all of those changes are really force you, like you're not learning about a new model at the same time. You're taking a model like someone else maybe thought about that and now just trying to convert that. And I think that that's awesome. And also, I feel like I guess the most surprising part of this is I would imagine NASA trying to mathematically solve for these like paths as sort of the first idea. But after you said it makes total sense that you start out by just like having strong intuitions about what makes sense, and then only after you try to actually solve that mathematically. That's also very, very cool. So how did you approach all of these tasks? Like I'm guessing before that, did you have a background in astrophysics, or did you have to learn everything on the fly?
Yeah, it was really difficult because not only was I not, you know, a skilled software engineer at the time, I was still in my first couple of years of undergrad, but I also had no background in decision making under uncertainty. So I was trying to learn that, learn Julia, and be a decent software engineer at the same time. So it was really difficult, but I was and still am today, even though I don't really do a lot of work in the space anymore. I think decision making under uncertainty is so interesting, and POMDPs are so interesting because the use cases are so cool. Like the original reason that a lot of this work was done in Julia was because there's a lab at Stanford, the Intelligent System Labs at Stanford, basically built all of the state of the art POMDP and MDP solvers and infrastructures at this lab at Stanford because they sort of just made a bold bet on Julia a while ago, and I think I was trying to digest as much of the many as the resources as possible that were out there around decision making under uncertainty. Tried to get involved with some of the coursework, like there was some good coursework at Stanford that was available, and yeah, asking as many questions has served me well in that sense, but I don't have any I don't have any good tips. I think there was still a lot of things like this was the real challenge for me in that internship. I think the software engineering stuff got a lot easier. The Julia stuff actually got a lot easier over time, but I think I just had some like my teammates in a lot of cases, the people who I was working with were well beyond my decision making under uncertainty understanding. So I was like always trying to like get over the hump of like in conversations and in as we were iterating and trying to solve these problems, like just those fundamental misunderstandings, and it made it really difficult. And I think it made me appreciate like, hey, if I want to be successful in things, like I should probably go and like have some domain specific knowledge that I can leverage in order to be successful. And I think that's sort of pushed me in a lot of ways. And when I do machine learning stuff, and it was the same thing in Apple when I did machine learning stuff, where you know everyone on my team had a PhD background, and I was coming with an undergraduate degree in computer science, and like trying to again, you know, do as much as I can, learn as much as possible without having that PhD background. I think it's hard, but it's also given me the motivation to, hey, maybe I should actually go and do a PhD and have that background.
Fair enough. Guy, my co-founder, has this saying that the best job you can find is when you're the dumbest person in the room, because you can only go up from there. So I think that's a very healthy approach. The other takeaway I have for this, for people that are maybe looking for their first opportunity in the industry, is it seems like, right, and it's easy to tell, I don't know how to call this, like hustle stories, but it seems like you sort of had a huge amount of grit in just like reaching out to people that are related to something that you're interested in and just trying to see if you can get a meeting. I think that that's generally something that people underestimate. I was speaking to someone about this podcast, and saying that, like, describing what were the biggest challenges, and I was saying that one of the biggest surprises I had starting this is that the guests that I bring on, some of them are very impressive people, such as yourself. If you would have asked me before I started whether or not people of this profile would be willing to come on a podcast and just talk for an hour or an hour and a half, in some cases, the my sort of expectation would be that they wouldn't, right? But surprisingly, you just reach out to people, and as long as it's an authentic and personal sort of outreach and not some automated message, I think that people sort of respond very strongly to that. And I think that also relates to sort of the way you described finding your first opportunity at sort of NASA of all places. So I think that's something that other people can take, regardless of if you're looking for an internship at NASA or some other awesome workplace. Yeah, just reach out, and you might be surprised by the response.
I just want to double click on this for a second, and I agree with you. I think a lot of the like hustle culture stuff is overblown, but I truly do think like for myself at the time, like to give perspective, like I hadn't yet started at Harvard. I transferred to Harvard to finish my undergrad. Like I was at community college at the time. I was working at the Apple store part time. Like I didn't have some like crazy background where people were like, "Oh, this is such a natural fit for you to come in and intern at NASA." I didn't have any other software engineering experience prior to that. I had just taken whatever like the intro classes were, but truthfully, like the differentiator between me getting that position and me not was spending a considerable amount of my time applying for internships, trying to build my skills, all that sort of stuff. And like the other story that's was happening at the same time as this was, again, I was trying to get an internship. I ended up emailing like every single computer science professor at Stanford. I found like the directory and just went down, read about what their interests were, sent every single one of them an email, or their administrative assistant an email, and every single professor emailed me back and said no. And like that's like, if you want to have success and have those opportunities, like you have to put yourself in the position where people can say yes. And if I hadn't emailed those people, then it was a 0% chance probability. But even if it's only a 1% chance, like there's 100 professors at Stanford, so maybe one of them are going to say yes. And I think that has always given me perspective. And it was the same thing at Apple for me too. I went back and I tweeted this out a couple of years ago when I started full time at Apple, but it took me, while I was working part time at the Apple store, I applied 538 times or something like that to
Wow.
different roles at Apple. And like I got one internship offer, which ultimately turned into my full time job at Apple. So like you have to put yourself in that position, and it doesn't, like in hindsight, it looks like, oh, even when I look at back at my own LinkedIn or my own career path, I'm like, oh, it was so linear and it makes so much sense that all these things sort of led to one another, but like in the moment it didn't feel like that at all. And I think people sort of wash that part of their background away, which in reality it's never that sort of, unless you're really lucky, it's never that sort of linear path to get where you are.
That's a good takeaway. I think that I guess related to this, most of the people I speak with, even people that have had sort of opportunities like the ones you described, don't end up being sort of a face of a programming language. So at least to me, right, you are the face of Julia. And so my question is like, first, how did you get to that? So you covered sort of when you first met the language and sort of figured out what it is and how it works. But from there to sort of leading the pack in a sense. And yeah, in general, like why are you excited about it?
Yeah, these these are great questions. So I think as far as how I got to where I am today, so again, I was making those contributions in the ecosystem, ended up sort of over time, over the course of that 2 years, getting more involved. At the end of 2019 or like the middle of 2019, realized that a lot of the programming indexes that like rank how popular languages are base a lot of those rankings on Stack Overflow questions. And
Mm-hmm.
the Julia community was predominantly using, we have our own discourse instance. So we don't send people directly to Stack Overflow, generally because Stack Overflow has a sort of toxic culture and there's a lot of challenges in that sense. So we can really control the vibe on discourse. So we're like, hey, come to discourse. We'll treat you with respect. We're not going to belittle you for asking simple questions like people do on Stack Overflow. But ultimately, like that's had an adverse effect of like, I don't think Julia is as well ranked on a lot of those programming indexes as it should be because they don't take into account the fact that we have, 100,000 plus questions on our own discourse instance, because those aren't on Stack Overflow. They're like, oh, Julia is not growing because, Stack Overflow questions aren't growing. So I sort of started working with people in the community to figure out like, how can we not sort of push away from discourse, but also make sure that we're having a representative
Represent.
presence on Stack Overflow. And that ultimately, again, got me even more involved in the community. I really enjoyed that experience. Led our Google, I forgot, Google season of contributions, or I forgot, oh no,
So
Google
the
Code-In.
summer of code.
Google Code-In was actually the first one that I did. So
Mm.
Google Code-In was for high school students. So I led that back in
Mm.
2019, and it was, again, got to mentor, like we mentored like 212 students, which was incredible, and such a fun experience. And I had just ended up emailing Viral and Avik, which were two of the project leaders, and I was like, hey, would love to get more involved in an official capacity, doing like educational material work and like helping people learn the language. And they were like, yeah, that would be awesome. We'd love to have you. And then, like 2 months into me doing that work and really focused on educational stuff, they were like, "Hey, we actually have this community manager title that no one has right now, and do you want to have this community manager title as like your official title for the work that you're doing?" And I'm like, "Sure, I guess that's okay with me." And then, sort of overnight, when I assumed that title, the scope and breadth of the responsibilities that I have sort of changed dramatically. So now I don't just focus on like creating content and advocating for Julia. Like I do a bunch of other stuff within the community now, like running all of our student programs, educational initiatives, partnerships, all that kind of stuff, which is actually a ton of fun, and I I like it a lot. But it's not like a traditional developer advocacy role where I just go and write articles about how to do cool things in Julia all the time. Like that's definitely part of it, and I really enjoy that part of it. But it's also like honestly, it's on the ground, like doing work that no one else really has time or bandwidth to do, but is really critical to ensuring the success of a healthy ecosystem. And as far as being the face of Julia, I think that just is like people's own little like microcosm, like bubbles of who they follow online and stuff. I do not want to or claim to be the face of Julia. I think there's a lot of people who are doing um, much more interesting work, and I think my job really is helping make sure that those people are getting exposure to the work that they're doing. So maybe I'm doing a bad job if people see me as the face of Julia instead of folks who are doing more of the hard work.
There might be other faces. I'm just saying that I think I'm trying to think back to the first time um, I sort of saw someone speaking about Julia. I'm not sure if you instigated that conversation, but I'm pretty sure I saw a comment made by you there. So you're doing a good job. I think that like so we have a pretty big developer relations and community team at Dags Hub. I think that part of the job is I don't know if you define it in a similar way, but like being present, right, in the places where community members are, and that's sounds like a simple task, but it's actually really hard, especially when the community starts to grow and people are everywhere. You can't see everything, you can't experience everything, so you try to sort of I don't know, share the spirit of how you think the community should be and the core values and everything, and hope that people are like-minded and spread the word in sort of a way that makes sense. But that's a very very hard task. So yeah, so I sympathize and empathize with everything that you're saying. But I also think, by the way, that the way you define sort of the community advocate or community developer advocate, I think it's very similar to the way we think about these things, which is looking at developer advocacy as like a narrow job of like writing blog posts and code snippets. I mean, it's not that people that are doing this are not good at their job or anything, but I think that sort of the developer relations umbrella consists of a lot of other things. And I think it's also good for people, and I get the vibe that you're this type of person that want sort of a more varied workload, right? So you can focus on different things according to what you're interested in. So that sort of makes total sense to me. I guess let's dive into maybe more. I don't know if this is a controversial topic. To me, it seems like one of the contexts in which Julia is brought up is like the old um, scientific programming language battle. So the major contenders are Julia, of course, and then Python and R. I think each one of them has their like core communities around them. But I'm curious, like, where do you stand on this question, and yeah, and why?
It's a difficult so one, I think that everyone in this ecosystem can be successful. I don't think that Python being hyper successful and being the most widely used programming language in the world means that the Julia ecosystem can have success, and same thing with the Python ecosystem. I think it's always about how can we do this in a really like how can we have that conversation in a really constructive way that sort of appreciates the nuances of the conversation. Like, I have this Julia developer community advocate hat that I wear, but I also have the hat that I wear as a member of the board of directors at NumFocus, which is the organization behind Jupyter, Pandas, Scikit-learn, our OpenSci, Julia. So it's truly like a mix of all these languages. And I'm always trying to be sort of level-headed in the way that I do things just because of that role as well. And I don't want to sort of obviously, I feel really strongly about the future of Julia and the problems that it solves, but I also want to sort of, out of respect for my colleagues at NumFocus who are on the board and in those positions and created those projects, like there's a ton of people who I really look up to, have put a lot of time in their career and their life into building the Python ecosystem and the R ecosystem. So I think it's always tricky to have that conversation and not diminish the work that those folks have done when truly, like, again, the Python ecosystem by all accounts is the most successful programming ecosystem ever created. More people are using
Mm-hmm.
Python to write more code and solve more problems than any other programming language in history. So I think it's a sort of admirable goal for us to strive to be where Python is, but the reality is that Python is 20 years ahead of where Julia is. Technically speaking, they've solved a bunch of problems that we still probably haven't solved in the Julia ecosystem. And truly, Julia was created to actually put Matlab out of business. So if we continue to compete with Python and R, that's fine. But if MathWorks goes out of business in 10 years because Julia is free, open source, and can solve a lot of the same challenges that Matlab does, I think that would be a success story. And it's just not the challenge with that narrative is that like it's less interesting to a lot of people because you're not really using MATLAB unless you're like in a corporation, like doing like that type of like, there's a very specific computational workload that people are using MATLAB for. And it's
Yeah.
not often the same workload that like people are talking about on Twitter all the time. It's much easier to be like Julia versus Python. And again, there's still a lot of similarities between Julia and Python, and there's a lot of benefit that you could get by going from Python to Julia in some cases. But again, really, when you do the value add comparison between Julia and MATLAB, it becomes even more clear that you should make the transition. Julia's open source. It has the runtime characteristics that are much better than MATLAB. It's
Mm.
just we haven't fully developed a lot of those simulation capacities that MATLAB has done really, really well, and that's really what people are using it for at the core. But I think there's a lot of work that's happening to get Julia to the point where it's going to be, a true MATLAB competitor.
Okay, so not to put you on the spot, but let me ask you a harder question. So if let's throw in MATLAB like into this mix, right? So we have now four languages, and by the way, like my impression of, so I used MATLAB when I did the quantum optics research in university. I think that the main advantage was simulation. Like we needed to simulate quantum states. You have a bunch of computations that are running, but in the end, you want to visualize that in a way that makes sense, and you can have sort of a meaningful discussion on which experiment you should run next, right? And that was very easy to do in MATLAB, probably decently easy to do in Python. I was not aware of Julia at the time, but I guess my question is like, where do you map these things? Like if I came to you and I asked you like, when do you recommend each language sort of is best for something? How do you map those four out?
Yeah, it's a good question. I think a lot of it, truthfully, like I don't know who came up with this saying, but I've seen it a bunch of times. Like the best tool to solve a problem is probably the tool that you already know how to use. So a lot of the time you see folks who are making the transition to Julia from one of these languages, once they reach the sort of computational limit of what's possible. And I think going back to my team at NASA, like a lot of the reason that the decision was made to go to Julia and actually use it to solve these problems was because the simulations that we were running were, on the order of 8 hours or a day if you were running them locally on your computer. And that was using Julia. So if you had been using, Python or Matlab or one of those other languages that were, an order of magnitude or two slower, it would have been, a week to run a simulation. So that's generally like the experiences that I've had talking to people who are, and I ask them, hey, what made you want to make the transition from Python or MATLAB to Julia? They say, I kicked off a simulation run. I don't work at some fancy place where I have like access to massive HPC and I can just throw more compute at the problem. So I kicked off a simulation run. I knew it was going to take 2 days or something like that. And during that 2 days, I started exploring, what are the faster alternatives to this problem that I'm having? And potentially for those in the case of MATLAB, what are the cheaper alternatives to this problem where I don't have to, pay MATLAB or pay MathWorks hundreds of thousands of dollars every year for my subscriptions. So that tends to be what it is. And I also think that the more there's like a bunch of different niches for the Julia community that are springing up where it's truly the Julia alternative to doing a lot of those processes is like the best in class. And I think right now, the best in class scientific machine learning software is being written in Julia. So if you're someone who wants to, and I'm not really in this field right now, so this is just my high level understanding, but like if you're somebody who wants to combine, ordinary differential equations in Julia to model like pharmaceutical drug discovery, like that niche in Julia has the most state of the art tools, and you can solve those problems most effectively using Julia. If you're somebody who's just doing like deep learning, want to do sort of image classification at some big company somewhere, like PyTorch and Python are 100% the right tool that you should be using. There's not even a question without a doubt. So it really sort of depends on like where you specifically fall, and then also again where you fall in the sort of spread between research and production needs, which I'm sure we'll talk more about later. But I think that's also an important characterization to make.
Fair enough. Is there a place where I could discover these use cases in which sort of Julia shines?
Yeah, so I think right now, and I'm open to suggestions from you and from folks in the broader community about how to do a better job of making these available. But right now, a lot of them are actually on the Julia Computing website. So the quick disclaimer is that Julia Computing is a for-profit business that was created by the creators of Julia, actually, so that they could build use cases and like computational tools again to compete with MATLAB around the Julia language. Julia itself is open source, all that stuff is open source, but they're sort of building commercial products on top of Julia at Julia Computing. And they have a nice, if you go to their website, there's like a case study section somewhere. And they have like, pages and pages of really cool use cases that they've seen companies use Julia for. And I think that we need to, as the Julia open source community, not that it's been super beneficial that Julia Computing has done a lot of this work for us, just because I don't have unlimited time and like just another thing for me to have my hands in would be difficult. So I appreciate that they've done a lot of this work, but I do think that there should be some equivalent version of this, and we've had the discussions before, even with some of the folks at Julia Computing, and they agree that we should do that on our own website as well.
Yeah, that makes sense to me. I mean, I would expect to maybe, if I were now sort of objectively looking for this, I would probably Google like awesome Julia or search on GitHub for awesome Julia, and then see what people are doing. I sometimes do this not for the actual projects, but to see what categories exist in these repos, because that usually defines the categories that are most interesting to people. So then that could sort of guide me in that direction. But this is just like me shooting from the hip here. But yeah, I
Another
think that there's yeah. Sorry, go ahead.
No, I was going to say another really interesting one is, and part of another sort of indicator that I look at is where people are building Julia companies, and another one is
Mhm.
in the graph computing space. So I've seen a bunch of companies sort of springing up around graph computing, graph databases. So, and I think that's probably just in general, people are more interested in graphs these days. But I think
Yeah.
it's really interesting that a lot of the money that's coming into the ecosystem is around the graph database and the graph computing ecosystem as well, which is kind of cool.
Interesting. I wasn't aware of that. So I guess in the context of production, right? Because and this is the MLOps podcast. I'm curious, like, if I'm using Julia or I'm excited about Julia, are there any special considerations for getting the work that I'm doing into production? Is it easier? Is it harder compared to doing it with a Python model or like a Python machine learning model or something else that I maybe created and I'm more familiar with?
Yeah, I think right now the biggest barrier for folks doing that is truly the knowledge about best practices and and making that information available. Like I think from a technical standpoint, like it's all the same considerations you would make when you are bringing some sort of Python program or model into production. I think that
Mhm.
Julia just we need to do a better job of like if you type, bring your Python model into production on Google right now, you'll find like 150 pretty decent quality articles that'll like walk you through the nuances, and there's enough variance in those articles that like they'll probably fit whatever your use case is. And this is something
Mhm.
that I think is one of the biggest problems in the Julia ecosystem, which is that if you don't have enough educational resources to help people, like they're not going to use your language. They're going to go find another tool because they can't figure out how to do those things. And I'm not going to sort of trial and error my way into taking this thing into production. I'm just going to go use another tool because it's going to be faster than me trying to figure it out with Julia. So I think we need to do a better job of this. That said, there's probably also some production edge cases in general once you get to a large enough scale that people may not have come across. And I think one example of this that comes to mind, which is um, actually a cool success story in my mind, a company called Relational AI. They again are using relational databases, and they have like a layer of machine learning that's on top of these databases that they give to commercial clients and partners and stuff like that. I'm not affiliated in any way, but a bunch of people in the Julia community work there and have contributed to a lot of their projects. One of the problems that they had, they're using Julia sort of from the core to do a lot of the database stuff, to do a lot of the computing that they're doing. And there was a bunch of challenges as they scaled up to actually having like a massive database in memory. That Julia's
Mhm.
garbage collector was like sort of behind the scenes causing havoc and chaos for them, based on my
Oh, no.
understanding. And they ended up making a bunch of like really, really great open source contributions back to the core Julia ecosystem to solve a lot of these garbage collector issues and to provide tools to better understand how the garbage collector was actually working behind the scenes. So I think there's those edge cases where if companies potentially aren't willing to sort of engage in the open source community, that you might find yourself at a disadvantage versus someone like Relational AI who's like, yeah, we want to be involved in the ecosystem. We know that it's not at the scale of Python yet, and that's actually an advantage to us because our competitors aren't using Julia, and we can leverage the ecosystem. And maybe we have to make a few open source contributions here and there, but like we can still, all things considered, like get more value than somebody who isn't using the ecosystem.
Yeah, I think that you could also argue that making open source contributions is a good marketing move, plus good for hiring. So
Yeah.
there's a lot of sort of objective advantages. Also, I'd say that there's the product perspective here, which is if Julia solves a real problem that can't be solved, as you said before, like the tool you already are familiar with is probably the best tool. So if you're going to Julia and moving from something else, that probably means that the tool you're using is just like not up to the challenge. And in which case, like if Julia does solve the problem that you have, the other maybe smaller problems that it presents are something that you would be willing to deal with. And the other thought I have is you mentioned sort of um, you mentioned the challenges and the fact that you need to be willing to face them in order to get sort of the benefit of putting Julia into production. I think that maybe the counter example that comes to mind is Jupyter notebooks, which are, again, not to step on anyone's toes, but notoriously not the best fit for productionizing your code, but still, I think, have made unquestionable impact on the community because they sort of go so much towards the side of ease of use and ease of get started that you get something basically for almost nothing very fast, and that's extremely valuable in and of itself. So you could also argue, and I know that Julia has I now forgot the name of this, but you have like an equivalent for Jupyter notebooks, right? Pluto or something like
Yeah,
that.
and yeah, Pluto and the JU in Jupyter is stands for Julia. Like it's one of the core pieces of Jupyter when the project was created, however many years ago.
Hmm. Fair enough. Right. I guess that makes sense now. So yeah. So the I think that the value could be had there, and then you do still need to bridge the gap over time. But again, if you create actual value, then people will be willing to overlook some gaps in return. So I'd like to ask maybe a few higher level questions just to get your thoughts on them. First is, what do you think is the most exciting topic in machine learning or MLOps right now, and why?
Yeah, it's an interesting question. I think overall in machine learning right now, and I'm a little bit biased in this, but I think there's probably more interesting stuff. And I was just listening to a podcast episode talking about semi-supervised learning, and apparently there's been some like revolution in the last 6 months in that field. So I'm like, I need to get my hands dirty and figure out what's going on there. But I think I'm still super bullish in general in transfer learning. I think transfer learning is sort of the way that deep learning becomes more accessible and solves more problems, and using pre-trained models and then fine-tuning them for specific problems, I still think is one of the most underrated things. And everyone has this idea that we need to go and create some new model architecture from scratch to solve some problem or something like that. And the reality is, like, people have done the hard work for you. You can use transfer learning, you can solve problems with extremely high accuracy without doing a lot of that work. And I think that makes the ability to solve those problems more accessible. So I think I'm really excited about that field, and I think I've been listening to a lot of the stuff and reading a lot of stuff that Jeremy Howard has been putting out around transfer learning for the last 3 or 4 years, and he's really the person who put me on. So the credit goes to him in that sense. And then with respect to machine learning in production, I think, or machine learning ops in general, I think just the fact that there's so much investment being put into solving these problems and making it more approachable is something I'm really excited about. Like, for example, when I was at Apple, we were managing our experiments and like a GitHub repo. Like, we didn't have, like, the results were sort of all over the place. We wrote a lot of custom reporting stuff ourselves. So, like, I always like to say, like, even at Apple with unlimited resources, tons of engineers, like, we still didn't have like a really great way of managing the machine learning cycle when we were solving these problems. And I think there's just so much opportunity for um, obviously big companies like Apple, but everyone in general to have access to amazing tools like DAG's Hub and so many others that are out there. So I'm super excited about what type of innovation that leads to overall, giving people more access to tools and information about how the models they're training are performing over time and things like that.
I think that first, I guess on the MLOps front, I totally agree. I think on the sort of the machine learning point that you made, I think is interesting. Um, first, I think that the equivalent here is in like software engineering. If you're using a database, you don't start by writing a database from scratch. You just use something that someone else built, and then you put your data in it, and you get a bunch of benefits just from doing that. So I think that designing sort of the core architecture for the next state of the art model is probably not something that everyone will do. But using that state of the art architecture and then adapting it to your needs is something that's going to be made more and more accessible. I think that that sort of will. We're already seeing this shift, but everyone is talking about data centric AI. I started thinking about a different term, which is like infrastructure centric AI. I think that there's a lot of work to be done around these processes that make getting value out of these models make more sense. But also, I don't know how many people in the audience are interested in biology. There was this time period where we mapped the first genome, and I think the first time it cost us like literally $1 million or $2 million. And then over the next few years, we've gotten to the point where mapping your genome is, I think today, something like $700 or $800. So the like 3 orders of magnitude less, right? And I'm guessing that in the next few years, we'll get to the point where it's really affordable for anyone just for the kicks. You don't even have to be sort of wanting to spend a huge amount on this. But now it's less than an iPhone, right? So that's a pretty big leap. And I saw this tweet a few days ago. I don't remember the name of the company, but a company is now like offering services. Like they claim that they generated a very efficient pipeline to retrain GPT-3 from scratch on custom data for, I think the price they said was $350,000 or $400,000. So that's still not cheap. But if I remember correctly, OpenAI spent like $10 million on it. So there is a huge, like, we might get to the point where even retraining from scratch is something that's affordable and achievable. Definitely for what will then be legacy models like GPT-3. But maybe we'll get to the point where, like, a few months after a new state of the art model comes out, people can retrain it for an affordable price, which I think would be pretty awesome, especially since I'm like at least emotionally heavily invested in open source data science. So democratizing those processes would be incredible. So I totally relate to what you're saying. Yeah.
Yeah, and I think a lot of this is already happening. I was listening to another podcast a couple of weeks ago talking about how this gentleman, I forgot his name, like sort of made an equivalent version of Dolly in an open source capacity. And yeah, I think there's so much cool innovation like that happening where people are taking some of these commercial products, doing it, faster in an open way, and making it, making that technology accessible. Because obviously OpenAI shared the research papers and stuff like that, but you don't have access to the code, you don't have access to a lot of
Mhm.
the sort of the fine tooth details of what's available there. I also think part of something that I'm generally concerned about is that it seems like people talk about like the AI winters and how a lot of the innovation slows down and things like that. And it seems like right now we're in this explosion of companies doing incredible stuff with AI and a lot of breakthroughs happening. It seems like every week on Twitter, I'm like, I can't keep up with all the stuff that's happening. And one of my fears is that with the current looming sort of financial conditions, that a lot of that innovation will slow down, or companies that have are on the crust, the whatever the word is, of like really close to being able to make some of this really cool technology work, are not going to make it through this cycle, and then we're going to sort of lose that innovation. And some companies going to be a couple weeks away from being able to train GPT-8 or whatever it's going to be, that's going to have like better than human level abilities to do these types of things, and they're just going to run out of money because of the current conditions, and they're not going to have, the VC community is not going to care because they don't have the sort of results to share yet. So I'm hopeful that this sort of bust cycle won't be bad, and it won't lead to a huge slowdown in a lot of the innovation that's happening right now.
Yeah, yeah. I'm an entrepreneur, so I feel like I'm biased to be optimistic at all times. But I feel like the first principles approach here is if you are generating real world value and something that people can actually use and care about, then you should be okay. And if you aren't specifically, like if a specific company fails, another will replace it and be successful because it's something that people will actually get value out of. That's not probably, you could probably find an edge case where that isn't true, but I feel like it's more often true than it isn't. And then for other things, like, yeah, I think in a sense, the periods of time where the economy is not as blossoming as others is times when you need to focus on what's important so that you could do these other things later. I think that's generally good advice. But I agree with you. It might mean that there is a slowdown period and then we re-accelerate later. Hopefully we don't get to that, but we'll see, I guess.
Yeah.
Making predictions is hard, especially about the future. So yeah, I guess one last thing before recommendations. I would love to hear how you keep up to date with everything that's going on, especially as we just said, a lot of things are going on. And then also specifically because you mentioned that you sort of learning things that you had sort of no knowledge of before a certain role is something that you had experience with. So yeah, how do you keep up to date with stuff? And then how do you learn something new?
Yeah, lots of different approaches that I think I've tried over the years. As far as how I'm staying up to date on a lot of the things that are happening today, I love Twitter. I'm on Twitter all the time. Definitely the best, most interesting. There's Twitter with a little sprinkle of LinkedIn just to know what people are sort of really excited about and they're posting on LinkedIn. So yeah, just trying to find the right people to follow, trying to find the right sort of conversations to be a part of there. A lot of I spend too much time driving right now, which actually kind of sucks. Going back and forth to see my friends and go places in Chicago. It's much more driving than I was doing in California. So I'm actually spending a lot more time listening to podcasts. So trying to find all the best machine learning podcasts. This one obviously is on the list, and listening to those and trying to make use of my wasted time sitting in the car, which has actually been really nice because I think I'm like I truthfully, like, my honest unfiltered opinion is that, like, I have a really hard time if I'm not actively doing something else, like listening to audio only. Like, I have to, like, I need the video to, like, keep me engaged and see it. And even if it's
Mm-hmm.
something like deeply technical, sometimes it's hard for me to, like, sit down and, like, in my, like, relaxing time and, like, do that. So podcasts driving has been the perfect combination for me. Like, I almost, like, have to be driving to listen to a podcast. So lots of that to keep me engaged. And then as far as the approach to learning new things, again, this is a bad answer, but school is actually really, really helpful for me. Like, just because, especially with a really busy, constrained life with lots of things going on and tons of obligations and tons of things that I need to get done, having the sort of, like, I can be self-driven in general to do a lot of things, but, like, on top of everything else, it's really hard. And I think I had the realization probably 3 years ago that it's really hard for me to be a self-driven learner on top of everything else that I'm doing. So I really need the structure and I need someone there and I need deadlines to sort of help me learn. So, like, law is a good example of this. Like, I realized, hey, I'm doing all this open source stuff. I really probably want to have a better understanding of law and the legal implications of everything that we're doing. So I was like, I guess the best thing for me to do is, like, do a formal, I'm doing a Master of Science in Law because I needed that structure to, like, help me learn. And it would be great if I didn't have to do that because I pay too much money for school. But it's also like, it probably wouldn't happen if I didn't have the structure of, like, a class and deadlines and assignments hanging over my head. But it's been helpful, again, especially for things that are very outside of what I'm doing. If it's something that's related, the thing that helps me learn the most is writing an article about it. Like, that's my motivation. Anytime I see something new and I'm like, I want to get my hands dirty with X, Y, or Z, and it's technical and it's related to programming, I'm like, how can I do that with Julia? And how can I show other people how to do that with Julia? And then it's that sort of, I get to learn and share with people as I'm learning, what's interesting, what the nuance is, and it's so much fun. I love doing that, and it's something that I'm always trying to find more things to write about in that sort of capacity.
I love that. I feel like people, again, in the spirit of like hustle culture, there's all those sayings of like, you can learn everything on your own and things like that. And I sort of, I agree. In theory, you can learn everything on your own. But for many people, the main advantage of going to a formal, going through a formal education is that it's formal and someone sort of beats you on the head with a stick if you don't like serve in your homework, or go to the tests, exams, whatever. And that's helpful to a lot of people. And I think that you also made a really great distinction of like, if this is something that is part of the core subject that you're working on or something like that, learning it on your own is much easier because you have the context. But if you're now venturing into a new field that you have no idea about, it's often really hard to know where to start. And one place to start could be whatever university, some less formal course or something like that, that helps you know where to start from. Obviously, there are the challenges of knowing which one to choose, like either which university or which course to go after. But I think there you can get recommendations more easily, as opposed to following a very complicated schedule of topics that you need to cover. So yeah, I think that's a great recommendation for learning. And yeah, let's last but not least, recommendations for the audience. If you have any, it doesn't have to be data science related or related to any of the topics that we covered.
Any specific context for, well, like what type of stuff do you have? Do you want to give a recommendation? I don't know if you have
Sure.
one that I can sort of base mine on. I have one in the back of my mind, but I'm interested to know what you have to say as well.
Yeah, so I feel like people have a tendency to either give life tips in this section or share like Netflix series, books, movies, stuff like that. So yeah, my recommendations are probably, on the book side. I am now reading the second book in the Three Body Problem trilogy. It is sci-fi. It is attempting to be as realistic for a sci-fi book as possible. As I mentioned, I'm an astrophysics nerd, so it sort of speaks to the things that I care about. It is very interesting. I think I mentioned this in another episode when I was reading the first book. The author is sort of like the original book was written in Chinese, and I have not read a lot of sci-fi books that sort of come from that cultural background, and I think it's very interesting in that regards. There are a lot of similarities, there are a lot of differences, and obviously it's hard to attribute that to culture versus the specific person that wrote it. But I think it's very interesting, and unique and enjoyable. So I really recommend that. And then on the series front, I am now going through Hunter x Hunter, which is relatively well known anime series. If you are into that kind of thing, I'm enjoying it a lot. I'm still in the middle, so don't send spoilers my way. But so far, it's pretty awesome. So those are my recommendations.
I love that. I need an Amazon link for this book. I really have a hard time not reading only nonfiction. So I think something that's like close to reality, like based in reality, but also a little bit more fun to read, I think would be awesome. I have three really quick recommendations. One for a series or for a movie to watch. Amazon Prime. It's called 13 Lives. True story about how the Thai soccer team that got trapped in a cave was sort of
Hmm.
how they helped get them out. Literally the most crazy and insane story that I've ever seen in my entire life. So stressful, but I think a great story about sort of what happens when you get humans to sort of put their lives on the line for other people and really try to do something that seemingly is as impossible as going to the moon. So it's a absolutely crazy story. Would suggest folks check it out. Um, as far as one other quick recommendation, just because it's that time of the year, if you're interested in contributing to open source,
Hmm.
now is the perfect time. I just saw something from Udine about Dags Hub and Hacktoberfest. So there's so many opportunities to contribute. If you haven't, if you're a practitioner in the field and at some company and want to sort of get your hands dirty doing machine learning, or you're just beginning your open source journey, there's a plethora of opportunities right now. People are really going, like, sort of setting aside time to specifically help people who are making their first contributions right now during Hacktoberfest. So get involved. Hacktoberfest.org, I think, is the website, I would imagine, or .com. Check out DAG's Hub, check out Julia. There's tons of other amazing projects if neither of those are your specific niche of interest. But there's no better time sort of in history to get involved in open source than right now. So I would highly encourage folks to get involved if they're not.
That is an amazing recommendation. I should have remembered that myself. Yes, do contribute. Open source is important. It's awesome. You have sort of an event set up just so you have an excuse to contribute. If you if you like joining in on these things, I think this is an amazing opportunity. And there's also a lot of swag involved. So if you're into that, you can make this worthwhile for yourself. That's a great recommendation. So I guess with that, Logan, thank you so much for taking the time. This was awesome. I really had a lot of fun. Until next time.
Yeah, I greatly appreciate this opportunity. I think it's so fun to see the work that you and the whole team at DAG's Hub are doing, and I'm wishing you the best of luck and success. And you have me as whenever I'm talking to people about MLOps stuff, I'm like, have you heard of DAG's Hub? And people are like, oh yes, I actually have tried it out. So I've had actually a couple of interesting conversations with people as I've been talking about the ecosystem. So congrats to you and your team, and thanks for having me on again.
Thank you. And thank you to the audience for joining us. I'll see you next time. Bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.